Welcome to the notes for 5.2. This section is also pretty short, so it's going to go by pretty quick. Make sure you have it. If you need to rewatch it, just like we've been talking about, please do. Remember that these are always going to be here for you if you need to go back and watch things again or look at them twice. It's totally okay and really a good thing. All right, so in this section, we're going to multiply and divide rational expressions. Remember that when we multiply fractions, any fractions, like if I multiplied a half times a fourth, I multiply straight across. So a half times a fourth is an eighth. If I did a half times 2/3, same thing would be the case. But one of the nice things that I can do, so I can multiply straight across here, I'd get 2/6. And then I would have to simplify, right? Because I need my fraction in lowest terms. 2 and 6 are both even. We can divide them both by 2. That would give me 1/3. The thing to remember, though, is that with fractions, one of the things that we can do, as long as there was a multiplication sign, and this only applies to a multiplication sign, it does not apply to a division symbol, an addition symbol, a subtraction symbol, nothing else. As long as the two fractions are joined by a multiplication sign, I can cross cancel. So what that means is I can see these two 2's right here, and I can go, oh, they're going to multiply through to each other. They kind of count as a 1. They can go. And if I do that, when I multiply straight across, you'll see I get 1/3. I simplified ahead. It's just doing the steps in a different order. It's an important thing to keep in mind because what we're going to do is multiply rational expressions. So the first step, every single time, let me say it again, every single time, is to factor anything that needs to be factored. If there's nothing that needs to be factored, super, but honestly, that's not what this class is. Most of the time, there's going to be something that needs to be factored. That's what we're playing here. Once you have factored and canceled anything across that you can cancel, or even within the same fraction, then multiply the numerators and denominators straight across, left to right. Then if you have to simplify it all, do that. Sometimes you'll get to the end and you'll go, oh, look, I can still simplify it. That's fine. But make sure what you end up with is completely simplified. So here's an example. So first step was always to factor completely. So we're going to take it one piece at a time. Okay, I'm going to start with the 5a minus 5b. They have a common term, so I'm going to take it out. I'm going to get a 5a minus b. The denominator of that fraction is 10. It is what it is. Over here on the right, the 2 stays because that's just a 2. And then on the bottom, what do I have? I have a difference of squares, right? So that's going to be, oh gosh, I didn't give myself enough room there. It's going to be a minus b times a plus b. So now stop and look. What can you cancel? What's going to multiply across? Because really what's going to happen is all the things in the numerator are going to get combined, all the things in the denominator. What can be simplified right now? Well, a minus b and a minus b, right? And then let's look at the numbers. 5 goes into 10 twice, so that becomes a 1, that becomes a 2. True? 5 and 10 are half. And then also I can cancel out this 2 and this 2. I did a lot of simplifying. So as I multiply straight across, on the top I only have a 1 left. And yes, if there's nothing left in the denominator, there's always, the numerator, there's always a 1 left. And then on the bottom, all I have left is a plus b. Finished. Okay? All right, let's try another. Same idea here. You try it first, please. So let's see what happens. Let's take it one part at a time, just like we did. So on the numerator of the first fraction, I can take out a 3. That gives me y of 3 times y minus 2. On the bottom, it's just 6y. I'm going to live with that. Times, let's look at the top. It's not an AC test because there's no number larger than 1 in front of the y squared. So I need to multiply to 2 and add to 3. That's going to be y plus 2, y plus 1. All right. And on the bottom, what do you see? I see a difference of squares. So that's going to be y minus 2, y plus 2. Now stop. Use your eyeballs. What do you see that you can cancel that's repeated either in the same fraction or across the multiplication sign, diagonally? Well, let's see. I have a y minus 2 and a y minus 2, right? I have a y plus 2 and a y plus 2. And then the 3 and the 6 can simplify. That becomes a 1. That becomes a 2 because 3 goes into 6 twice. And let's see what I'm left with. Well, if I multiply straight across now, I have y plus 1 on top. And I have a 2 on the bottom. Done. Okay. Let's try one that is a little scarier looking. Because honestly, even when they're scary looking, the steps are exactly the same. That is the joy of algebra. You look at it, you say, okay, what are the steps I need? And you take it one piece at a time. Do not let looking at something like this overwhelm you, because that's not what it's doing. Or sorry, you don't need to let it do that. Just take it one piece at a time, one step at a time. So I'm going to take this one step at a time. So out of the top, I can take out a 4. W minus 5p is left. On the bottom, let me think about the bottom, right? If I take a 2 out of this first, I got a 2, and then I have w squared minus 25p squared. Well, that is now a difference of squares. So I'm going to do this in 2 pieces. I have the 2, and then let's see, I'm going to have w minus 5p, because that second p is just a hitchhiker, remember, and w plus 5p. All right, multiplication sign. The numerator of the second fraction needs the AC test, right? Maybe? Yep, it does. So let's look. 15 times 2 is 30. I need to, sorry, negative 30. Add and subtract to negative 30, or multiply to negative 30, add and subtract to 7. So I would say negative 10 and 3, right? Or positive 10, positive 10. So I'm going to rewrite 2w squared plus 10wp. I'm going to run out of room. Rats. I'm going to erase that so that I can give myself some space. So let's see, 2w squared plus 10wp minus 3wp minus 15p squared. All right, now I'm going to group, right? My groups are just a little funky looking. Let's see, out of the first group, I can take a 2w. That gives me w plus 5p. Out of the second group, I'm going to take a negative 3p, and I'll get a w plus 5p. So I'm going to do my groups down here. I'm going to pull my common term to the front, w plus 5p, and group my rest, 2w minus 3p. And then I'm going to do the denominator. Let's see, common term looks like a 3, so that's a w plus 3p. All right. Oh, something's wrong. Something wrong? Let's see. 3w plus 3p. Nope, I'm good. Okay. So now let's take a look at what we can cancel, right? And we did that one piece at a time, one piece at a time, one piece at a time. Just take it one step at a time. Don't let it overwhelm you. All right, so let's look at what we can cancel. I see 2w minus 5p's. That works. I see 2w plus 5p's. All right. I see a 2 and a 4. That becomes a 2. I think that's it. If they don't match exactly, I can't cancel things. So let's see. In the numerator, I'm going to end up with 2 times 2w minus 3p. In the denominator, 3w plus 3p. And I'm finished. I don't need to multiply through. You can if you like, but it's not necessary. You can leave that just the way it is. Okay, it's finished now. It's simplified. Let's try this one. All right, you try this one. one step at a time, one pair of factors at a time. Your final answer should be p plus 4 over 5p plus 1. If you have questions about it, ask them in chat or the discussion board, please. All right. Let P, Q, R, and S represent polynomials. This is about division, okay? There is nothing changes when we do a division rather than a multiplication except the first step, right? When we divide two fractions, let's say I have a half divided by a fourth. The first step in every case is to take your second fraction, use its reciprocal, and turn the symbol to multiplication. So 1/2 times 4 over 1. And then I get 4 over 2. I get 2. That's exactly what this says here. So the only thing that changes in a division problem is that I take the reciprocal of the second fraction, change the symbol to multiplication, and then the steps that we just did are exactly the same. Factor, simplify, multiply. Okay? So let's try it. I'm going to have not enough space for this, but okay. So let's see. I'm going to rewrite and flip first. So I have 8t cubed minus 27 over, and that one looks like it's in a funky order, actually. So while I'm looking at that one, I'm going to take out a -1 and flip it around. 4t squared minus 9, just to make my life easier right here. That's okay. And then I'm going to change my symbol to multiplication and use the reciprocal of the fraction, flip it. So 2t squared minus t minus 3 over 4t squared minus 6t plus 9. Now factor your way through. Let's look at the numerator of the first fraction. That looks like a difference of cubes, doesn't it? So set yourself up. Minus sign goes first because it's a difference. Let's see, cube, the base there is a 2t. Base there's a 3. 2t squared is 4t squared plus 2t times 3 is 6t plus 3 squared is 9. Okay. I'm just going to let that be. Let's look at the bottom. That is a difference of squares, isn't it? So I have the -1 out here, and then I have 2t minus 3, 2t plus 3. Multiplication sign. Let's look at those factors. That is an AC test, right? So I'm going to look at that guy up here. 2 times -3 is -6. So I'm going to use a -3 and a 2. So I'm going to rewrite 2t squared minus plus 2t. I'm going to do that first. Minus 3t minus 3 group, right? So I can take a 2t out of the first one, and I'm left with t plus 1. And I can take a -3 out of the second one, and I'm left with t plus 1. So my groups there, I'm going to have a t plus 1, and the leftovers is 2t minus 3. All right, let's deal with the denominator. Oh, another AC test. Bummer. 2. Oh, and I didn't. No, I did. Okay, I'm looking at the wrong thing. I'm going to do that one. That helps. 4 times 9 is 36. I need to multiply to 36 and add or subtract to -6. So let's see. Oh, but wait, look for a second. Use your eyes. Do you notice something when we factored? I'm going to leave this guy right here. I'm not going to factor it. Can you see why? Because this right here is the exact same as this factor here. I'm not going to bother with it. It's just going to cancel. Sometimes when something looks complicated to factor, take a second, look around, make sure you actually need to do that work, okay? All right, let's, oh, that should have been a plus sign. My signs are wrong. So that should have been a minus and a plus. Did you see my mistake when I made it? There it is. Okay, it happens to all of us where we get a sign backwards when you're not paying attention. It was a sum of squares. Silly me. All right, so now we can continue to cancel because those should have matched and do. All right, so I see a 2t plus 3. I see a 2t minus 3. So now we look at all this. Look what happened. I have that -1 can apply to any part, so I'm really just going to put it out front in the t plus 1. And there's nothing left in the denominator besides a 1, so I don't even need to write it as a fraction. So this whole mess up here simplifies to that. Okay, let's try one more. All right, same thing this time. Let's do it. So I'm going to just rewrite first because this is a division. 5x cubed minus x squared. Change to multiply and flip 25x squared. Oops, I need the 5. Minus 1. 10x squared plus 12x plus 2. All right, one thing at a time, right? Numerator of the first fraction, the common term is x, so I get x plus 1. Denominator of the first fraction, the common term is x squared, right? Yeah. So I got 5x minus 1. All right, let's look at the next one. That is a difference of squares. So it's going to be 5x minus 1, 5x plus 1. And now this is an AC test. So 10 times 2 is 20. I need to multiply to 20 and add to 12. That's 10 and 2, right? So I'm going to rewrite. Okay, and now I'm going to group. I'm going to take out 10x. I got x plus 1. I'm going to take out 2. I got x plus 1. All right, so I'm going to go down to the denominator, and let's see what I have. I have x plus 1. And, oh, you know what? When I group this, I'm going to have 10x plus 2, right? That's not simplified all the way. I can actually pull a 2 out of that, and I can get 5x plus 1. So I'm going to put that 2 out front here and 5x plus 1 here. Sometimes what you do is you sort of see what else is around in the problem, and you think like, do I have one of those? I'm going to use that to sort of inform how I factor here. All right, so let's see where we have. We have a 5x minus 1. We'll get rid of that. We have a 5x plus 1. We have an x plus 1. And then I can simplify this. That goes away. This just becomes x. So this whole mess, when I multiply across, I need to keep a 1 in the numerator, is just that. It's pretty nice, actually. Handy, handy. All right, so this is the end of the notes for this section. You should do the practice in ALEKS. You should rewatch this if you need. You should ask questions if you have them. Please, in the discussion board, over email, wherever you need to do that. Please reach out if you are stuck. I will see you in the modules.